Hi children, in today's lesson I'll teach you the multiplication operations with fractions, and of course this subject has subtitles. The first subtitle is, as you see, multiplying fractions on number line. And from our previous lessons, if you remember, we had started the subject addition and subtraction operations uh, with the meaning of, again the same, with the meaning of these operations on number line. So the order is the same on the subject, like addition and subtraction operations with fractions. Now we know the meaning of multiplication operation. In the first example, on the first page of our subject, 8 times 2 over 5. We know the meaning. I should write 2 over 5 in addition 8 times. The first one 2 over 5 plus 2 over 5 plus 2 over 5. 2 over 5. This is the fourth one. Continue to write 2 over 5. 2 over 5. 2 over 5 and 2 over 5. 1, 2, 3, 4, 5, 6, 7, 8. I added 2 over 5 8 times. This was the meaning of multiplication operation. Now we know how we may show this addition operation on number line. I prepared before for you the number line, and denominator is very important with working on number line. 5 is very important. Denominator of our fraction is 5. It means I should divide a whole into 5 equal parts. What is the meaning of whole here? The interval between two consecutive integers. For example, the interval between 0 and 1, or 1 and 2, or 2 and 3, and so on. So I should divide each these types of intervals into 5 equal parts. Now write here 0. After 0, 5 over 5, it means 1. 1 comes. After 1, 2 comes 10 over 5. After 2, 3 comes 15 over 5. And that's all. Now, I divided before each interval into 5 equal parts. For example, between 0 and 1. 1, 2, 3, 4, 5. Between 1 and 2. 1, 2, 3, 4, 5, as you see. Now, write here 8 times 2 over 5. Now, for the first 2 over 5 in the addition meaning of this multiplication operation, 2 over 5, I should count 2 units. Why? Because each unit is 1 over 5. So to reach 2 over 5, I should count 2 intervals starting from 0. 1, 2. For the first moment I reached 2 over 5. But I should show here 8 moments. What about the second moment? I should reach here 4 over 5, 1, 2. I should reach here 6 over 5, 1, 2, and then 8 over 5 for the fourth moment. What about the fifth? I should reach 10 over 5 or 2, then 12 over 5, then 14 over 5, and then at the last and the 8th moment I reached finally 16 over 5. It means the result is 16 over 5. Now if you checked the result, the numerator is 16, comes from the multiplication with 8 and 2. 8 times 2 is 16 because what about the denominator of the final result? 5. 5 comes from here. There is no change in the denominator here. Now let's continue with the next example. My fraction here in this multiplication operation is 3 over 2. The meaning of denominator, you know now. Divide the whole into two equal parts. So start from 0, between 0 and 1. 1 is here, 2 over 2. After 1, 2 comes 4 over 2. After 2, 3 comes 6 over 2. After 3, 4 comes 8 over 2. And after 4, 5 comes 10 over 2. After that, 12 over 2. And this continues like this. And each interval divided into two equal parts. Between 0 and 1, for example, 1, 2. Between 1 and 2, 1, 2, 2. And between 2 and 3, 1, 2, and so on. What is the meaning of 4 times 3 over 2? It means I should make addition operation like this. 3 over 2 plus 3 over 2 plus 3 over 2 plus 3 over 2. I should write 4 times. So I should make in this addition operation 4 movements, and each movement should have 3 over 2 units. I should count by starting from 0, 3 units. 1, 2, 3 for the first movement. I reached here. For the second, 1, 2, 3. I reached here. For the third, 1, 2, 3. I reached here. For the last, the fourth one, 1, 2, 3. I reached finally 12 over 2. It means 4 times 3 over 2 is 12 over 2. It means 6. Now algebraically, the multiplication operation may be made like this. For the final result, multiply 4 with 3 and write the result as numerator of the final result. 4 times 3 is 12. What about the denominator of the final result? 2. Right here, 2. That's okay. I think you understood the meaning of multiplication operation with fractions on number line. These two examples are enough for us. Now on the next page, there is another subtitle, multiplying fractions with models. We have models, two models, and as you see for the first one, but we should write the multiplication sentence to describe the shaded parts in each model. In the first picture, I have 1, 2, 3, 4, 5, 6 equivalent rectangles, and each rectangle divided into 4 small equivalent rectangles, and 2 of them were colored. How can I express or represent the shaded region as a fraction for this small rectangle? 2 of them were colored, and I have in total 1, 2, 3, 4 rectangles, equivalent rectangles. From 4 rectangles, 2 were colored. So I may represent the colored region as a fraction as 2 over 4. I have 1, 2, 3, 4, 5, 6 finally. So I should multiply 2 over 4 with 6. We know algebraically how can we find this result. Finally, multiply 6 with 2. 6 times 2 is 12, and right here 4. The result is 3. What about the second one? I have 2 equivalent pentagons, and for each pentagon divided into 5 equivalent triangles, and 3 of them were colored. So if you represent or show the colored region as a fraction for a pentagon, you should write 3 over 5. 5 is the total number of triangles. 3 is the number of colored rectangles. And I have 2 pentagons, so I should multiply with 2. Again, and finally, multiply 3 with 2 and the result is 6. Write 6 as numerator of the fraction and 5 is the denominator. Now this is another way, another model for multiplying with fractions. And on this page, as you see, there is another model. Find the product using the area model. This is question type. And let's start from the first one. Now I have a huge rectangle here, and this rectangle divided into 1, 2, 3, 4, 5, 6, 6 plus 6, 12 equivalent squares. And follow me, I have a rectangle, I have this rectangle and divided into, this rectangle divided into 6 equivalent squares and 4 of them were colored as you see. So the same thing can be told for the second one. So horizontally I have a rectangle and the shaded region may be represented with 4 over 6. What about the vertical one? The vertical one you may see from here. This rectangle divided into 2 equivalent and one of them is colored. So if you represent the colored region, you should represent it with 1 over 2. You know from our previous lesson, so we are multiplying this. I think you couldn't understand anything, but I think you understood the meaning of 4 over 6 and 1 over 2. We are multiplying them. If you multiply them, multiply numerators with each other. 4 times 1 is 4 and 6 with 2, 12. 4 over 12. 4 over 12 is the final result. Now, clean and consider this figure totally. As you see here, we have 4 common regions for these two types of fractions. They are colored for both these two types of fractions model. In the vertical and in the horizontal, these 4 squares colored, and in the vertical rectangle again here colored. So here colored, here colored, here colored for both types. And it means in total we have 12 squares, right here 12, and 4 of them are common, colored for each two types. Right here 4. I think you understand. Now let's come on here. For the horizontal one, the shaded region represented with 1 over 2. Clean it, clean. And for the vertical one, again the shaded region represented with 1 over 2. We are multiplying these two types. Clean. And for the vertical one, as you see for the vertical one, this region shaded for both types, namely horizontal shade and vertical shade, colored region are common, or there is only one colored region common. So in total we have 1, 2, 3, 4, and only one is common. So I should write here 1 over 4. So actually we should multiply 1 over 2 with 1 over 2. Multiply with 1 and 1. The result will be 1. 2 and 2, the result will be 4. This is algebraically. Okay. This is another model, area model. Now let's continue with the next subtitle, multiplying fractions with by cross cancellation. And as you see, we have two examples and you will understand easily. We have two fractions here. 9 and 2 are numerators. 10 and 3 are denominators of the fractions, respectively. Now, is there any simplification between the numbers numerator and denominators? And between 9 and 3, we have 9 and 3. They both divisible with 3. So divide 9 with 3, the result will be 3. Divide 3 with 3, the result will be 1. What about 10 and between 10 and 2? Both divisible with 2. Divide 2 with 2, the result is 1. Divide with 10. 10 with 2, the result is 5. So I am multiplying 3 over 5 with 1 over 1. It means multiply 3 with 1. 3 times 1 is 3. And 5 with 1. 5 times 1 is 5. The result is 3 over 5. What about this? Is there any simplification between numerators and denominators of the fractions? For example, between 12 and 16. They both divisible with 4. If you divide both of them with 4, for 12 you will get 3. For 16 you will get 4. And what about 18 and 8? Both are divisible with 2. If you divide 18 with 2, you will get 9. If you divide 8 with 2, you will get 4. And is there any other between 3, 9 and 4, 4? No, there is no simplification. So we are multiplying 3 over 4 with 9 over 4. Result 3 times 9 is 27 and 4 times 4 is 16. This is an improper fraction. We may write it as a mixed fraction. In 27 we have only 1/16. What about the remainder? 11. The remainder is 11 and 16 again is the denominator. I made the last result in my head. Don't worry about it, you will reach this speed. Now let's continue with the next page. I think you understand the cross cancellation. Now we have three numbers here to make cross cancellation. And there is a simplification between 3 and 3. If you divide 3 and 3 with 3, you will get 1. 1, 1. There is another simplification between 7 and 21. Both are divisible with 7. If you divide 7 with 7, you will get 1. If you divide 21 with 7, you will get 3. What about the 45 and 6? 45 over 6 times 1 over 3. I'm writing the remaining numbers, 1 and 3. 1 over 1. Sorry, it's not plus. And 1 over 1. Right here again, 1 over 1 is meaningless in multiplication. There is no effect of them. 45 divisible with 3. If you divide 3 with 3, you will get 1. If you divide 45 with 3, you will get 15. And finally, 15 times 1 times 1, 15. 6 times 1 times 1 is 6. Is there any simplification? Yes, you may divide both numbers with 3. And if you divide 15 with 3, you will get 5. If you divide 6 with 3, you will get 2. Finally, we reached this result. And in 5, we have two 2's. 2 and 1 over 2 is the result. What about this? I think you understand the cross consolation. Is there any simplification between, yes, numerators and denominators? 7 and 7. If you divide 7 with 7, you will get 1. What about 15 and 35? You may divide with 5. 3 for 15 and 7 with 45. What about 48 and 8? 6, because, 6 times 8 is 48. 48 is divisible with 8. Result is 6. If you divide 8 with 8, result is 1. So, in numerator, we have 6 and 3 in multiplication. 6 times 3 is 18. 1 times 7 is 7. In 18, I have 2 sevens. 2 times 7 is 14. The remaining is 4. Remainder is 4. 4 over 7. 2 and 4 over 7 is the final result. Let's continue. Multiplying fractions with whole numbers. It's very easy. 8 is 8 over 1. Multiply with 3 over 16 and make cross consolation. Between 8 and 16 we have cross consolation. Both are divisible with 8. The result is 1 for 8. The result is 2 for 16. Now, finally, 1 times 3 is the result. 1 times 2 is the result. So the final result is 3 over 2. It means 1 and 1 over 2, as if you write as a mixed number. What about this one? 17 over 19 times 38 over 1. Is there any simplification between numerators and denominators? Yes, between 38 and 19. 38 is divisible with 19. 19 over 19 is 1. 38 over 19 is 2. Result, 17 times 2, 38, 34, and 1 times 1 is 1. It means 34. I think you understand. Let's continue with the next page. Multiplication with mixed numbers. We may write any mixed number as improper fraction. You know the method. What about 8? 8 is 8 over 1 times, what about 1 and 3 over 16? 1 times 16 is 16. 16 plus 3 is 19. And 19 over 16 is the result if you change this mixed fraction to its improper form. Is there any simplification between numerators and denominators? Yes, between 8 and 16, they're both divisible with 8. 8 over 8 is 1. 16 over 8 is 2. 1 times 19 is 19. 1 times 2 is 2. This is the result. In 19, we have 9 twos. Remainder is 1. Sorry about that. 9 and 1 over 2. What about this one? 2 is 2 over 1 times, let's change this mixed fraction to its improper fraction form. 4 times 7 is 28. 28 plus 5 is 33. It's 33 over 7. Is there any simplification between numerators and numerators? There is no. There is no. So multiply 2 with 33. It's 66. And over 1 times 7 is 7. If you want to change or transfer to mixed fraction form, this improper fraction, in 66 we have 9, 7. 9 times 7 is 63. The remainder is 3. 9 and 3 over 7 is the final result. So if you have a mixed fraction, write it in its improper fraction form and then make multiplication operation. Let's make necessary simplifications. What about this one? We have two mixed numbers. Change them into their improper fraction. 4 times 6 is 24 plus 1, 25. 25 over 6 times, what about this one? 1 times 10 is 10, 10 plus 4 is 14, 14 over 10 for this. What about the simplifications? Between 25 and 10, both are divisible with 5. 25 over 5 is 5, 10 over 5 is 2. What about 14 and, for example, 6? Both are divisible with 2. 14 over 2 is 7, 6 over 2 is 3. Finally, multiply 5 with 7 and 3 with 2. There is no simplification between numerators and denominators. 5 times 7 is 35. 3 times 2 is 6. And finally, in 35 we have 6. 5 times 6 is 30, remainder is 5, and denominator is 6 again. Now let's continue with the next one. Change these two mixed numbers into their improper form. 7 times 2 is 14, 14 plus 1 is 15. 15 over 2 is its improper form. What about this one? 2 times 5 is 10, 10 plus 2 is 12. 12 over 5 is its improper form. Is there any simplification? Yes. Between 15 and 5, both are divisible with 5. 5 over 5 is 1. 15 over 5 is 3. What about 2 and 12? Both are divisible with 2. 12 over 2 is 6. 2 over 2 is 1. Multiplication. 3 times 6 for numerator. 1 times 1 for denominator. What is the result? 3 times 6 is 18. 18 over 1 is 18, and the final result, we reached 18. Now let's continue with the next page if we have any question. We have 3 mixed numbers. Change them to their into their improper form. 2 times 6 is 12. 12 plus 3 is 15. For the first one, 15 over 6 is the improper form. What about the second? 5 times 3 is 15. 15 plus 2 is 17. 17 over 3 times 1 times 5 is 5. 5 plus 2 is 7. 7 over 5. Now, at the bottom, or in the denominators, as you see, 3 times 5, you will multiply. 3 times 5 is 15. So 15 over 15 is 1. What about 17 and 7 and 6? There is no simplification between them. So I should multiply 17 with 7 and write here 6. 7 times 7 is 49. We have 4. 7 times 1 is 7. And 7 plus 4 is 11. 119 over 6 is the result. I don't need to write again it in its mixed form. Okay, now let's continue with the next one. Change them into their improper fraction form. For the first one, 1 times 3 is 3. 3 plus 2 is 5. 5 over 3 times 9 times 2 is 18. 18 plus 1 is 19. 19 over 2 times 4 times 4 is 16. 16 plus 2 is 18. 18 over 4 for the last one is its improper fraction form. What about the necessary simplifications? Now, between 3 and 18, I have, yes, both are divisible with 3. 3 over 3 is 1. 18 over 3 is 6. And what about 2 and 6? Both are divisible with 2. 2 over 2 is 1. 6 over 2 is 3. Is there any? On the bottom, I have 1, 1 and 4. And the top, 5, 19 and 3. There is no, so I should multiply 5 with 19 with 3. And at the bottom, 1 times 1 times 4. It's 4. I wrote the result only. Okay. Now, 5 times 3 is 15. 15 times 19 over 4. What about the final result? Let's multiply somewhere. 19 with 15. 5 times 45. 5 times 9. And 5 times 1 is 5. 5 plus 4 is 4. 1 times 9. 9. 1 times 1 is 1. 5. 18 and 2. 285 over 4 is the final result. Now let's continue with the next page. I think multiplication is over. I think you understand all multiplication types on number line and on as algebraically. Okay, how can you make in a short time? Please try to make many examples and try to make many simplifications, cross simplifications to reach the result in a faster way. Now, of course, multiplying fractions by word problems is one of the most important subtitles of this subject. Now, let's read the first question. Sorry about that. Adam needs to drive a distance of 372 miles to attend a seminar in New York. He stops over to grab a quick bite after the covers, yes, 1/3 of the total distance. How many miles has Adam driven? Now, he driven 1/3 of the whole one. So I should multiply 372 with 1/3. And I know this 372 is 372 over 1. And is there any simplification between the numbers? Yes. You may divide 372 with 3. 3/3 is 1. In 7, I have 2 3's. 2 times 3 is 6. 7 minus 6 is 1. 12 in 12, I have 4 3's. It's very easy for me to make this operation. But if it's hard for you, please divide like this in another place. Okay? Make this operation. This number is divisible with 3. You will see at the final. Okay, you know this division method. Okay, how many miles has Adam driven? As you see, 124 miles. Now let's continue with the next one. Ramona is tasked with solving 35 problems. So she should solve 35 problems as part of a math assignment. If she solves 2/7 of the problems, how many problems does Ramona solve? I should find the 2/7 of 35 problems. It means multiply 35 with 2/7. 35, you know, 35 over 1 is 35 over 1. And there is simplification between 35 and 7. Both are divisible with 7. 7/7 is 1. 35/7 is 5. So I should multiply 5 with 2 on the numerator of the final result and 1 on the denominator. 5 times 2 is 10. 10/1. 1 times 1 is 1 because, so 10/1 is 10. So how many problems does Ramona solve? 10 problems. Okay, now let's continue with the last one. Tom, who owns a retail shop, had 456 cans of cheese in stock. Well, in total we have 456. If he sold 2/3 of the stock, now he sold 2/3 of 456 in a week. How many cans did Tom sell? That's very easy. Again, we should multiply 456 with 2/3. Is there any simplification between the numbers? Between 3 and 456? Yes, it's possible to divide with 3. Now let's pass to another place and make this division. In 4 I have 1. In 15 I have 5, 3. In 6 I have 2. 152. This is 1 and this is 152. So finally I should multiply 152 with 2 on the numerator and 1 and 1 on denominator. If you multiply 152 with 2, 2 times 2 is 4. 2 times 5 is 10. I have only 1 in my hand. 2 times 1 is 2. And if you add 1, 304. You will reach over 1. There is no change. 304 is the result. Tom sold 304 cans of juice in. Okay. Now this was our last question. We learned many things in this lesson. Please try to make many experiments or practices to make or to solve the questions faster than now. Okay, now our lesson is over. We'll continue the division operation with fractions on the next lesson. Hope to see you on the next lesson. Bye.